Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Cheers. Got a kit to build today. It's a fairly old one that's been in Jaycar for many years. In fact, since 1994. It's called the Champ Audio Amplifier Kit KC5152 from Silicon Chip Magazine, February 1994. Now, this is a LM386 amplifier kit, and it says this tiny kit delivers half watts, 0.5 watts or half a watt into 8 ohms and can be powered from a 9-volt battery. It features variable gain and will happily run from 4 to 12 volt DC. Build this up in a few minutes, and funnily enough, this does only take a few minutes to build, no longer than 10. Kit includes PCB with overlay and all electronic components. Kit requires 4 to 12 volt DC power supply, optional case, UB5, and they reckon it can be built in 15 minutes, and it's a simple kit to build. Well, it is just an LM386 amplifier IC after all. There's only like about 4 or 5 external components. So let me just get this open. I'll get rid of this staple, because I tend to always prick myself on staples when trying to pull them out of packaging. So, so 1995, that makes this kit 30 years old. So here is the bag of components. They give you some solder, and there's the little tiny PCB. IC and IC socket, which is good to see. It's actually in anti-static foam, which makes a change. 2 10 microfarad capacitors, 220 microfarad capacitor, and I think that's 100. Yeah, 100. And some PCB pins. Nice. And the instructions. So here's their component guides. It just shows you all the different types of components and what they're identified as on the schematic symbol, plus a really useless resistor color code chart that's not in color, but at least they've marked what the colors are. But yeah, this is not really useful because, well, I like the color code chart that's actually in color, but I have several of those in different magazines and books and stuff anyway. So what I'm interested in is not how to identify components. Geez, this is all stapled backwards, isn't it? So, build the Champ, a handy audio amplifier based on a single IC by Darren Yates. Now, I have done a video in the past of a 1 watt design, discrete design that he did. It's linked in the description, and it works a little bit better than the LM386. So this is the schematic diagram. It's basically taken from the data sheet. It can run between 4 and 12 volts. There's the LM386 IC. This volume potentiometer is marked as a logarithmic, but the one supplied with the kit is an open carbon trim pot, which is linear. Now the gain is set to roughly 41 with these two components. There's 10 microfarad and 1K between pins 1 and 8. Now you can change this gain by changing the value of this resistor. If you want lower gain, you increase this resistor. So if we're at 41 now, if you increase this to say 2.2K, you'd be closer to like 23. If you didn't include these two components at all, you would be at the default gain of 20. If you were to put a shorting link here, so you're reducing the resistance, we would be now at a gain of 200. So it's optional as to what gain you're going to operate at. I'm going to probably leave this at a gain of 41 because, well, it just seems alright for that. Pin 7 is decoupled here with this 10 microfarad capacitor to ground. What this does is it decouples the supply line and stops any hum and buzz and all that sort of stuff getting out to the output if this was running off of a plug pack, for instance, like a switching plug pack. That's all that's there for. It also does increase the high frequency response as well. So if you were to remove it, you may notice a lack of highs, and if you included it, you may notice an increase in highs. Output's taken out of pin 5 through this Zobel network featuring a 0.1 microfarad capacitor or 100 nanofarad and 10 ohm resistor to ground, and it's DC blocked by this 220 microfarad capacitor into the 8 ohm speaker. And that's pretty much it for the schematic. There's not much to talk about, it's just basically per the data sheet. So they've given us some graphs and stuff here, device dissipation versus output power into a 4 ohm and an 8 ohm load respectively, with a VS of 12 volt. Apparently the device dissipation in watts is over 1.2. That's dissipation, not power output. We're more like 0.35 watts at 12 volts with what looks like, a total harmonic distortion of 10%. So it's going to sound like absolute crap. And at 8 ohms, it's actually purported that it can produce at 12 volts with a dissipation of 0.8 watts, about 0.85 watts with a 10% total harmonic distortion level. Yeah, okay, that's pretty nasty. I mean, the LM386 is not a hi-fi amplifier. Let's get that straight. It's not a hi-fi amplifier, but it does the job of amplifying a weak signal such as from an electret microphone and putting it out to a speaker. And down here they've got the component overlay diagram, which is not really necessary these days because there's a silk screen on the PCB. But this was back in the days of 1994 when all PCBs in kit form had no silkscreen printing on them. I remember that. And you always had to have the instructions with the kit in order to get the overlay diagram so you could actually work out where all the components went. And it was a real bastard, depending on the size of the PCB with multiple components on it, is working out, okay, I need to put this component here, but where the hell is it actually on the physical board? You're looking around, because they show the traces on the underside on the top here, but of course on a real PCB you can't see them, you have to turn it over, so you're constantly doing this to put parts in, and it was a real pain in the ass. I'm glad that they've now gone to using silkscreen printing on the front of the PCBs. It makes it a lot easier to assemble. Yeah, but that's what they used to do back then. Blank. Okay, that's pretty much it for that. There's not much to talk about with the schematics, or the instructions. So I guess what we need to do is grab a pair of skizzers, and I'm going to first take out the PCB, which is really tiny. So that's a good look at that. It's typical Jaycar PCB. I've noticed that there's a lot of these boards which have extra holes that don't do anything. What I think those actual extra drilled holes in these PCBs are for is so some form of hook or something can be attached to the PCB so it can be dipped into a solution for tinning, because on the back here it's tinned. They're not like the Chinese circuit boards where it's manufactured with machines and stuff. Most of these are just done, I'm not sure who actually does these, but most of this tinning process is manual, so that's probably what those extra holes are for, is to provide hooks to dip it into a solution. So that's the circuit board. So I guess I need to get the parts out the bag. They do give you a length of speaker wire here to connect to the output, which is nice. I'm probably not going to use it. So I'm going to I'm going to take the PCB pins out separately. I'm going to drop those components in there, and I'm going to drop that lot in there. And I'm going to start assembly with the IC socket because that's the smallest component compared to the PCB pins. So I need to turn my soldering iron on and then we can proceed to assembly. So I'm not going to take much footage of this because I don't see the point. I'm going to build it and then come back and test it. So let's get cracking. Alright, I got the first few components in, the IC socket, which was a bit of a pain on the desk because I ended up shorting some pins together and yeah, I had to fix that, but that's fine. I soldered the PCB pins in, all 6 of them, and using this solder smells like puke. Just an FYI. I don't know why I told you that, but I did. Okay, so next I'm going to stick the 2 resistors in, the 10 ohm and the 1K, and then I'll put in the other higher components like the capacitors, and that should pretty much complete the construction of this kit. Should only take me another 5 minutes or so, so I'll see you then. Meat and 2 veg. There we go. It's assembled now. It only took me about probably an extra 7 or 8 minutes or so. So I'm going to pop in the LM386 now, and I'm going to keep the anti-static foam because they're handy for other ICs. So not that the LM386 is really susceptible to static, but you can never be too careful. I need to get myself an IC insertion tool. There we go. She is in. And it's ready to test. Positive goes there. Ground is there for the power supply. And the speaker output positive negative there. And input comes in over here and grounded there. So the easiest way to test this is to hook it up to an oscilloscope. So I'm going to hook it up unloaded for just the first preliminary test with a signal source going in. I'll preset this pot when I can find a suitable screwdriver that will fit in there to less than halfway. So it's about there, I think, which should do. I don't want, you know, too much signal going through. So I'll get things set up and we'll just see if we get an output on the scope, and then I will load it down and yeah, we'll see how it performs on the scope. I've just discovered a little bit of a problem here. I was testing it and it's drawing 150 mA for no reason, and I figured out why. I've put the IC in backwards and the socket by the look of things. Yeah, I have. Brilliant. Well, this is probably destroyed, but let me turn it the correct way around and I'll see if it's still functioning. If it is, I'll be surprised. If it's not, I won't be surprised. So that was a dumb rookie mistake. I'll have to correct that IC socket. That's fine. Oh no, it still actually does work. Oh my god, that is amazing. Holy shit. Alright, let me correct my mistake on the PCB and I'll show you what I'm looking at. You know, it helps to put the bloody thing the right way around. I'm surprised the IC survived. It was really getting red hot. So this time, the IC socket is the correct way around. So now I can solder that in with the solder that smells like puke. Yes, it's nice and solid in there, it's not crooked. This is what happens, you've got to pay attention to orientation of things. I somehow messed it up, I still don't know how. But, yeah, stuff happens. Alright, so now I can pop the IC back in for the second time, and this time it should work fine. So pop it in the right way around and turn the board up the right way so the electrons don't fall out. That's how it should look, with pin 1 facing the input connector, which would make sense because pin 3 is the input and that's where the pot is. Alright, So unloaded, that's what we can see on the output screen, on the oscilloscope screen. We can see a nice waveform. And it's pushing 2.64 volt RMS roughly. But that's kind of irrelevant for this because it's not loaded into a speaker or a dummy load. So I have the potentiometer set to about halfway on the board. So that's where clipping is. So yeah, it's not going to produce much power, but we can see that it's amplifying okay. I'm just touching the pot, by the way. Doing a heat test on the LM386, it seems alright. It's running at 9.1 volt and NAFL current draw. Right, so next thing is I'm going to load it into a dummy load. Not that I really see much point because we already know how it's going to perform into a dummy load. But I'm just going to do it anyway just to confirm that the IC is still okay, which I'm surprised that survived. I mean, it's not like they were in the 70s, resilient to a lot of things. They are very easy to damage these days. One dummy load. And I forgot to turn the circuit off before I changed the load, but it doesn't really matter. As we can see, the voltage has dropped off a little bit, and we're clipping, but there we go. We're pushing roughly 2 volt RMS out into 8 ohms, which is perfectly fine, and now we're drawing around about the 100 mA mark. So that IC is going to start to get quite warm. So because I'm going into 8 ohms and we're pushing roughly 2 volt RMS, it's pretty easy to calculate what the power is going to be. It's 2 volt multiplied by itself or squared, so 2 times 2 is 4, divided by 8 is 0.5. So there you go, half a watt. So I'm going to move my ground connections now over to the 4 ohm side and make sure that it still operates fine in the 4 ohms. However, it's clipping earlier now, but that's to be expected. And we're drawing more like 200 mA from the supply. Drop that off. Now we've only got 1.3536 roughly volt RMS. It's actually worse into 4 ohms. You're not really gaining much. So yeah, oh, those farts stink. That's what to expect though from the LM386. That's just what it is. So the next test would be to put it into a speaker and just see if it outputs sound. I have to have the heater on today, it's a bit cold. Okay, yeah. Yes, that's working and I'm swearing. This pot's actually wired backwards. So 0 is fully clockwise. So keep that in mind. Now I'm going to change that to 450. Sorry, 440. Nice. Change that to 100 hertz, I guess, for shits and giggles. Nice. Well, we can hear that works. That's great. Now, what did I buy this for? Well, considering it was only 10 bucks, 11 bucks, thereabouts, I thought, well, why not? Secondly, I don't think I ever did a video on it. And thirdly, I'm always wanting an LM386 output amplifier on a breadboard experiment or something. And sometimes I can't be bothered, you know, building it up on the breadboard. Just be handy to have a module just knocking about that I can just hook up to the circuit quickly. Plus, it's inherently noisy on the breadboard too. You pick up static and noise from the power supply, like I was last night. Which reminds me, I might, before I end this video, substitute out the spare LM386 IC I've got and see if that noise is gone, because I was picking up noise on this power supply. I could hear a buzz in the speaker. I want to just verify that the chips that I've got are working properly. Right, I've swapped out the IC now with one from Tron FX on eBay, who seems to be one of my best sellers that I've actually come across on that platform. no, it's perfectly fine. I'll stop the... There is no buzzing or crackling that was on the output last night when I was using that IC on breadboard. It's the breadboard. Okay, so that's going to pretty much end this video here. And I would play music through it, but there's no real point. We know it works. But it's a handy little building block for you know, audio testing and stuff like that. If you want to just a quick output amplifier to drive a speaker from off of something else, like a little preamp or something you're trying to build up on breadboard, and you don't want to have to mess around adding the components necessary to make a working LM386. It's just handy to have the module separate, in my opinion. But anyway, that's going to do it for this one. I hope you enjoyed it. If you did, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying, have a great day. Thanks for watching. 1970s, circa 1970s.